A company makes computer chips from square wafers of silicon. It wants to keep the side length of a wafer very close to 15 millimeters. And it wants to know how the area A of x of a wafer changes when the side length x changes. We want to find A prime of 15 and explain its meaning in this situation. So the first thing we're going to do is we're going to have a square. So let's go ahead and create a square here. Okay, so here's our square, right? And we know that if this side is x, then this side is x. Okay, so the area of x, meaning that the area of this is equal to x times x, which is x squared. Okay, and then we want to find the derivative of this. So what is the derivative of a of x? Meaning, what's the derivative of x squared? Well, the derivative of x squared is going to be 2x. So in step number 3, what we want to do is we want to find a prime of 15. So if we plug that in, we know that a prime of x is equal to 2x. So we want to find a prime of 15. So that's equal to 2 times 15, which is actually equal to 30 millimeters square per millimeter. So this is what we get for our result. Now, let's just say that if we wanted to plug in, so for example, let's say that if we said that the side x is going to equal 15. So if we plug that into our area formula, if we want to find a of x, then that would be 15 squared, which is equal to 225 millimeters squared. And then if we wanted to find the area for when we have x is equal to 16, then that would equal 16 squared. And 16 squared gives us 256 millimeters squared. And if we take the difference between these two, we get about 31, which is approximately similar to what we got for our answer in part 3. Okay, now what we want to do is we want to find out, okay, it says show that the rate of change of the area of a square with respect to its side length is half its perimeter. And try to explain geometrically why this is true by drawing a square whose side length x is increased by an amount, change in x. How can you approximate the resulting change in area, change of a, if change of x is small? Okay, so let's take the square that we got from up there. Okay, so we know that we have our square here, which is x and then x. Okay, and then what we're going to do is now we're going to create this extra sort of area to this square. So let me go ahead and write that in a different color here. So we're going to add, another section to this square. And then we have this other section of the square, right? So we know that this represents x and then this is x. And now this extra piece is now the change in x. And over here, this is the change in x as well. Okay? So let's take a look at this. We know that the a prime of x here, we know from the previous the derivative of that was 2x. Okay, and if we wanted to find the perimeter of this, we know the perimeter of a square is going to give us 4x. Okay, so what we want to do is we want to compare the new, increased amount of that side length to the old square. So we're going to have the area of the new and the area of the new is, we're going to take x and then add, so this entire side that we added is going to be x plus the change in x. And the same thing over here, this is x plus the change in x. So if we want to find the area of the new, we're going to multiply both of those and square them. So it's going to be x plus the change in x squared. Okay, and then the area of the old, we know, is equal to x squared. Okay, so what we want to do is we want to find the change in the area. Okay, well, the change in the area is taking the area of the new and then subtracting the area of the old. So the area of the new we determined is x plus the change in x squared minus the area of the old, which is x squared. So let's go ahead and then FOIL this. When we FOIL this, we get x squared plus 2x times the change of x plus the change of x squared minus x squared. So now when we combine like terms, we can eliminate the x squared. And so what do we get for the change in the area? Well, we get 2x times the change in x plus the change in x squared. Okay, so now we want to determine, how can you approximate the resulting change in area, change in A, if the change in x is small? So what we want to do is we want to determine, what is the change in A divided by the change in x? So that means that we have 2x times the change in x plus the change of x squared over the change of x. So we can factor out the numerator, we can factor out a change of x, and then what's left is 2x plus the change of x divided by the change of x. So therefore we can eliminate that to get 1. And so therefore the change in area with respect to x here is going to equal 2x plus the change in x. Okay, and so keep in mind that what we added up here is quite small. So when we look at the change of x into our square here, this is quite small. So therefore, this is actually approximately 2x.